Hello everyone, here we are recording and we are looking at a related rates problem. It says a pothole in the road in the shape of a right cone is increasing. That's a key word in size at a rate of 2 inches cubed per hour. What is the rate at which the radius is increasing? If the height of the cone is double the radius. When the radius is 1 inch long. So we're going to use the method over here of rip disk, right? Or rip disk, here we go. So we're going to first read the problem. So I read it here. You want to take a time to read it again. You can go ahead and pause it for that. And then you're going to identify the givens. In this case, it says we want to have the rate at which the radius is increasing. We know that we have this 2 inches cubed per hour, and that's going to, you notice the key thing is cubed, so that means it's going to be a volume, and because it's per hour, so it's d something dt, and because it's cubed, that tells me that's going to be v here. So this here is going to be 2 inches cubed per hour, or let me try per hour here. So that was kind of a dead giveaway, and that's something you can follow, is just follow the units. Volume is always cubed. What is the rate at which the radius is increasing? So I know dr dt, this is how the radius is changing. This is what I'm trying to find here, right? And it says the height of the cone is double the radius. So we know that the height is equal to 2 of the radiuses is the height, right? Because the height is double of the radius. Note, this here does not mean, so it's not that the 2h is r. This would mean that the radius is 2 times the height. That's not what this is saying here. And it says when the radius is 1. Okay, so I have my givens. Now I need a picture here. The only picture you really need is just to draw a road here, and then maybe if you want, you can draw a pothole. And we have a cone. And the volume of a cone, because there's stuff inside here, right? So the volume is 1/3 pi r squared h, and this is r, and this here is h. And so this picture actually helps us kind of figure out that my equation, I need an equation, or equations in this case. So I have this one, but if you notice here, if you try and do the next step, which is to differentiate with respect to time, what we get is, I'm going to go ddt of this v equals 1/3 pi r squared h. So what happens here is, I'm going to do this incorrectly, so this is going to be incorrect. If you notice, when you take the derivative here, I'm going to get some stuff, so some extra things that I don't have. So I know dv dt is, this goes along for the ride, so it's 1/3 pi times, this is the product rule here, so it's going to be d dt of r squared h. So this is going to give us here 1/3 pi, this is 2r times dr dt times h, the derivative of the first, times the second, plus the derivative of the second. The derivative of h with respect to t is just dh dt times the first r squared. So the problem with this right now is that, you see, if I have r, I have h, because you know that h is 2r, but I don't have dh dt here. So this is a problem here. So what I need to do is to get rid of it before I differentiate. So what we're going to do is we're going to go back in time now, and we're going to say, before I differentiate, I'm going to get everything in terms of r, because I know that r, or h is 2r. This means if I divide by 2, that h over 2 is r. So I'm going to put this in for, I messed up. So this is already solved for h.
Daniel, Nicola.
So I'm going to stick this
to the main office.
inside here for h. So what I'm going to get instead then, now this is going to be the correct one. Okay? So I'm going to get v equals 1/3 pi r squared h, and h is just 2r. Okay? And now I'm going to rewrite this, so I get 1/3 pi, 1/3 pi 2 r cubed, which just gives me 2/3 pi r cubed. I'm going to rewrite this up here, so I know that v is 2/3 pi r cubed. And now I have it just in terms of one variable, and if you'll notice, I'll be able to use everything I have to find the answer. So I'm going to take the derivative with respect to time. This gives me dv dt equals 2/3 pi times 3r squared times dr dt. And now we have everything we know. We need r is 1. dv dt was, 2. And now we just plug them in, and you would solve for dr dt. And that's pretty elementary at this stage, so you can figure that out by yourself.